Imagine a poison with no color, no taste, and no odor, a substance so lethal that a single gram introduced into a city's water supply could kill 50 million people. In November 2006, former Russian spy Alexander Litvinenko sat in a London hotel for a meeting. During the conversation, he drank a cup of green tea that appeared, smelled, and tasted normal. Within hours, his body began to fail. He experienced rapid hair loss, total organ failure, and a complete collapse of his immune system. He was dying from the inside out, yet doctors couldn't explain why. Medical teams frantically tested his blood for every known chemical agent. They looked for cyanide, arsenic, and thallium, but the results were consistently negative. There was no trace of traditional poison in his system. Investigators eventually suspected a radioactive source and scanned the patient with a Geiger counter. This device, designed to detect the most dangerous nuclear materials, showed the needle resting firmly at 0. The hospital was faced with a medical impossibility. Litvinenko was dying from acute radiation exposure, but the machines built to find that radiation insisted he was clean. This created a terrifying mystery. How can a human body be destroyed by radiation that the world's most sensitive detectors cannot see? The search for the answer leads back to 1898 and the laboratory of Marie Curie. She spent years obsessed with a strange glowing rock known as pitchblende. By boiling down tons of this ore, she eventually isolated a microscopic fragment of a brand new element, polonium. The element exhibited extreme properties, glowing blue and generating enough heat to reach 500 degrees Celsius through pure radioactive decay. Curie didn't know it at the time, but this discovery would eventually destroy her own bone marrow and take her life. Her research filled a critical gap in the periodic table, but the radiation that killed her also provided a blueprint for the element's eventual use as a weapon. Why did the Geiger counter fail? Standard detectors find gamma rays, high-energy waves passing through thick metal and concrete. Polonium-210 emits alpha particles instead. These are heavy and slow. They are so weak, a single sheet of paper stops them. Outside the body, polonium is relatively harmless. Its radiation cannot even penetrate the dead outer layer of human skin. It is effectively invisible to the sensors because it lacks the power to reach them. However, that weakness disappears if the isotope is swallowed or inhaled. Once it bypasses the skin, the situation changes instantly. Inside, those heavy alpha particles become microscopic projectiles. Unable to leave the body, they remain trapped, repeatedly fracturing living tissue from within. They physically slice through DNA strands. This causes acute radiation syndrome. The body loses its genetic instructions and cannot repair itself. In the Litvinenko case, it took a specialized urine test to find the alpha traces. He had been killed by a substance that costs $30 million to manufacture in a nuclear reactor, a weapon specifically chosen because it leaves no external footprint. The danger of polonium-210 lies in this physical paradox. It is medically undetectable while on the surface of the skin, but causes systemic mechanical cell failure the moment it is ingested. While Litvinenko's murder involved an expensive laboratory-grade dose, this same radioactive isotope is sold legally in every corner store and gas station. The path to the consumer begins on the farm. Tobacco growers use fertilizers containing apatite, a mineral that naturally holds traces of radium-226. As the radium in the soil decays over several years, it undergoes a transformation that eventually produces polonium-210. Tobacco leaves are covered in sticky, microscopic hairs that capture this radioactive dust. Once it bonds to these hairs, the polonium becomes a permanent part of the leaf that cannot be washed away. When the tobacco is lit, the smoker inhales these alpha particles. They travel deep into the lungs and become lodged in the alveoli, the fragile air sacs where oxygen enters the blood. The cumulative effect is staggering. A person smoking 1 pack of cigarettes a day receives a radiation dose in their lungs equivalent to undergoing 300 chest X-rays every year. Documents show that major tobacco companies have been aware of this radioactive presence since the 1960s. Despite knowing the risks of localized alpha radiation in lung tissue, the industry has never removed it from the product. Science provides us with the facts, but it doesn't choose how they are used. Polonium-210 is just an element on a table. It is human choice that determines whether it remains a scientific discovery, a state-sponsored assassination, or a hidden consumer toxin.